Hello, students and C++ learners on YouTube. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Camino College, Torrance, California. And today I'm here with you on C++ functions, video number 1. I don't know how many videos I'm going to have. I have some videos from the past, probably 7 or 8. I might do 3 or 4 more. So overall there might be 10 or 11. So let's get started. Software size measured in lines of codes keeps increasing. In fact, you may be surprised to hear that some programmers get paid by number of lines of code they wrote. And we are going to show you typical size of software in lines of codes in next slide. And this table shows complexity in software as number of lines of code. So typical Hello World program has 1 to 10 lines of code. There's data structure called stack and queue in C++ standard template library that would have lines of code anywhere from 10 to 100. And I teach at El Camino College. There's CS1 and CS2. CS2 is data structure class. Code lines may go from 100 to 2000. When you pursue your computer science degree at a university, in senior year you will do the capstone project, and lines of code in that might go from 2000 to 10,000. There's an operating system called Linux. Linux command line utility lines of code may be from 10,000 to 100,000. There's a compiler called G++ in Linux, and lines of code in that could be 100,000 to a million. Firefox browser that many of you use may have code line from million to 10 million. Microsoft Windows 2000 kernel may have lines of code from 10,000 to 10 million to 100 million. And Debian Linux operating system, another operating system, might have lines of code from 100 million to a billion. And Human Genome would have lines of code up to 3.3 trillion. Okay? So you can see that lines of code change in a vast range, and Human Genome is the latest software. You can see how big that is in lines of code. So let's keep this in mind as we go further. One of the challenges in writing Lab 5 was the number of lines of code was large. We also realized that code base in lines of code gets, as code base in lines of code gets larger, the software configuration becomes more and more complex. That increases the complexity in compiling and debugging. And clearly, no one can endeavor to write Firefox browser's 1 to 10 million lines of code just in one main function that you have been doing so far. I'm not even sure anybody will try and give up in like 10 minutes. So it's a matter of common experience that successful completion of a software project requires the software be decomposed into modules or functions, and each module or function can be coded and tested independently. And then modules and functions tested and debugged are integrated together to build the software. This is very similar to like if you're building a car, your whole car is not just one piece, your whole like main function. You build bodies separately, you build tires separately, you build seats separately, you build engine separately. drivetrain separately. Each part is tested, produced, tested, and then it's assembled. So building software today is very similar to that in structure. Okay. So software that has many functions. The function that we programmer design are called programmer defined functions. So what programmer defined functions do, they break down or decompose large software project into modules or functions. Industry has different names for functions and modules. Those are also called procedures, methods, sub-procedures, routines, subroutines. And if you want to communicate with professionals from different programming language, you need to remember all these names. Large C++ software projects are decomposed into functions, which are then tested, debugged independently, or then integrated and synthesized into one simple software project. Okay. All right. What are the techniques for decomposing into functions? Technology used in software decomposition into functions can be done by one of the two techniques. One of them is called a waterfall model. Other is called an agile development model. Discussion of these technologies is beyond scope of CS1. Therefore, we're going to proceed to discuss technology of writing C++ functions. Suffice to say, as you have known so far up to Lab 5, that every C++ program has at least one function called main. There are many ways. If your main got too large, complex main function can be decomposed into several smaller functions. Or you can design a complex software firsthand, top down, in many modules or functions which form the software structure. And as I said, the way part of aircraft form and structure of an airplane. Okay. Okay. What are the general rules about programmer defined functions? Depending upon software size, C++ program can contain many functions. Functions can call each other to complete software tasks. And main function can also call any of the functions in the software. Technically, it is possible to call main function from other functions, but doing that, however, may lead to software failure by a process called infinite recursion. Very important thing about functions is they should be atomic in the sense that each function should focus in accomplishing like one central task. So you saw that when we called sqrt function, all it did was got the square root of its argument and returned it. It didn't print it. It didn't take cube root of it. It didn't find tangent. It just did simple one thing, took the square root and returned it. So that kind of gives you a model of how to write functions. Programmer, to whatever degree possible, should avoid writing God functions. What do I mean by God functions? Where this God function does everything. Okay? Software is not written properly when we make one part of the software God software. Everything has to be decomposed to proper sizes. And if you do that, that wouldn't be much improvement over writing the entire code in main function if one function will do all the work. Okay? All right. There are two types of functions. Value returning functions. These functions return a single value to its caller, that means calling block. And such functions are called by placing function call to the right side of an assignment operator. We'll show that to you in a minute. And the other functions are void functions. Those are called just like an ordinary program statement. We compare them now. Value returning function always returns a single value to its caller and is called from within an expression. So function call is on the right side of assignment operator. Variable storing return values on the left side. Example like this. This is the variable double root val sqrt 5.1. During this function call, control is transferred to this code in sqrt. It gets the square root of that and it will return that square root and it will be stored into root val. But void function never returns a value to its caller and is called as a separate statement. So it will be like print 5. You're saying that, okay, take value 5, print it to the console. So notice this doesn't have a assignment operator or anything. This is like any other program statement. That's a big difference between the two. And two should be called this type of syntax versus that type of syntax. Okay, I'm going to remind often forgotten fact. We are once more reminding the oft forgotten fact and syntax. Example of calling value returning function is like below, and no parts of it are allowed to be left out. If I have function here, argument being passed to it is going to compute the square root, return it, and this part on the left has to be there to store the return value. So you can see function call is on the right of the assignment operator and return value is actually stored. That's the correct syntax. That's the required syntax. You cannot write this like this. This will compile. Actually, this should be smaller case s, but it is not allowed in CS1. Leaving out assignment operator this and this will compile, but it is useless. And useless code is burden on the computer. Software that places useless burden on the computer is a low quality software. Low quality software has no buyers and no points are given for it. Okay. Let's talk about value returning function concept in math. So you might have seen this in math. F of x equal to 5x minus 3. So f is the name of the function. X is one parameter of the function. If it had two parameters, we'll put a comma here and another one here. And that's the function definition, or you can also call it algorithm. So how does this function work and returns a value? When I have x equal to 1, I'll substitute value of x here, 5 minus 3. Then fx equal to 2, and 2 is the return value. If I put x equal to 4, 20 minus 5 into 4 is 20, minus 3 is 17. And in that case, 17 is the return value. So return value is determined by function definition or function algorithm and value of the parameter that is passed to it. So this concept from math is very similar in some ways to the concept of value returning functions in C++. Functions can also be thought of as software machines. We can imagine all C++ functions to operate like machines or like a black box. And in fact, some software machines are given a special name called virtual machines. One example of that is Java Virtual Machine is installed in your web browser to enable it to display Java applets. And that's one example of software machine or virtual machine. And let's show you some picture of a software that doubles an integer passed to it and returns it using machine model. So let's think of this machine here, this machine. We have input port, we have output port. Machine has the algorithm or a code that any number you put here would be doubled and shown at the output port. Okay, so how would this machine work? I input a number 2, I press the activate button, or you turn some handle or something. Then algorithm of doubling this number is executed and output will show 4. So you can think of this as a function machine. All function machine in software Excel acts like function machine. Function machine takes our parameters as argument. They use arguments, use them arguments and algorithm to compute and return value. After such computation, the computed value is returned to the calling block and is stored in the variable on the right side of assignment operator. In Excel, storing variable is the cell itself, and we're going to show you mechanism function call in Excel spreadsheet. And this mechanism is identical in all softwares. Let's go to Excel. I'll show you. So here I have, well, actually this should be function here, function. So imagine I have two arguments, 5 and 6, and then I have this function call here. This is the cell A2, this is the cell B2. Function name is max. So I inputted the value of A2 and B2, two arguments in this case. Function machine name is max. And if I click this button to activate the machine, what machine is supposed to do, find out the larger of the two and return to this cell. So you'll see that will happen. So max machine, software machine will do that for us. Take 5 and 6 as argument, determine which one is larger, return that and store that here, and you'll see it did 6. Okay, so same way here, sum. So it's taking two arguments, A3 and B3. Function machine sum is supposed to add them together, return it, return value is stored in this cell here, and if we click here, that should show us 7. Okay, then there's another function called min. Min means find me minimum of the two arguments I passed, argument 1, argument 2, and by clicking this I'm pressing the switch of the function machine, and it'll determine the smaller of the two and return and fill in this cell, and that should be 1. Okay, so that's pretty much how your C++ functions will also work. Okay, all right. Mechanism of function call. How do functions call happen? One function calls another by using the name of the called function next to a parenthesis, and this includes the argument list. And when that happens, function call temporarily transfers the control from the calling block to the called function. And eventually we'll show that to you in the compiler a little bit later. But during the call, control is transferred to a different piece of code, which is the code of the function, and it's transferred back to the calling block once the function call is completed. Okay, let's talk about design of functions. Designing a function needs decision to be made on following aspects, and importance of some of the aspects may surprise you. Data type of the value returned by the function. Number of arguments passed to the function. Theoretically, C++ has no limit on the number of arguments passed, but arguments needed are only those that are usable by algorithm inside the function. So you only pass those that can be used. Data type of arguments passed to the function, that's once again it depends on the type of algorithm that function uses. And then of course algorithm to be executed by the function. But this last one is the name of the function. Surprisingly, naming a function turns out as one of the most important and contentious part of the function design. We'll talk about that a little bit. Why deciding on function name is so important? Function names are sticky. Once a name is chosen, it can never be changed. If changed later, all the code written by the old function name will break. Take, for example, sqrt function in C++. Thousands of lines of code have been written using the name sqrt in the source code. If C++ is to change sqrt name to square root, then all the code lines that use the name sqrt will no longer work. They won't compile. And if that happens, in fact, if C++ would make even such a small change, it will kill the use of C++. Nobody's going to use the language anymore. That's why function name is so important. We'll talk more about this. Effect of function names being so sticky. Effect of function name being sticky is universal. Any new language coming to the market cannot afford to use a different function name for doing the task, name different that is already not being used by previous languages. And if it does attempt to do that, case in point, if it changes str to square root, okay, this may shock you. Such language will be dead on arrival. Dead on arrival. No one will use that language. It will not fly, even for a day. Why? Reason is simple. Programmers often copy and paste code from old languages and only make minimum changes to make the code work in the new language. If function name is different in a new language, that would reduce programmer productivity drastically. And programmers don't like to, well, nobody likes to work harder than they have to. Okay, more on names. Names are holy. Names are holy. Once chosen, they cannot be changed. Thus, the biggest discussion and fights during software designs take place in selection of function names. You probably never thought that's that important. It's the most contentious part of the software design. Everyone knows that once chosen, the name is stuck for the eternity. For this class, CS1, this paradigm is enforced in all labs. Students are not allowed to change name of functions. They are asked to code in labs. One more time, you cannot change name of functions that you are asked to code. One more time, you are not allowed to change name of the functions that you are asked to code. Serious dislocation in software development takes place if name agreed upon is willingly changed by programmer or by someone else. Okay, so now we discussed 4 parts of function design, of value returning function. Now we're going to name them one more time and do the design. We'll take something very simple because right now we cannot take something very complicated. By the time I do design example 5, then we could do more complicated. So we need to design these things: function name, return data type, argument list and data type of each argument in the list, function algorithm. So these 3 decisions are made by a design team. Single person does not design them. Okay, does not decide upon them. And once these 3 are decided, then these 3 cannot be changed after that. Programmer has only control over function algorithm. That could be changed. And that's a programmer's domain and responsibility. Okay, algorithm inside the function. In lab 6 in CS1 and 7, 8, 9, 10, we enforce this paradigm and principle. No one in the class can change these 3. You can only change this. In future courses, you may have more freedom, but not in CS1. Okay, so we're going to design a simple function to compute the cube of a number passed to it and return the cube value. And these are my design parameters. Name of the function is cube. You can have another name, but name cube is just as good. Return type is double, because that way function can return cube of int or double, either one. Function argument list, just one argument, that is the number whose cube must be computed and returned. And function argument data type is also double, because if you're passing a double, you can pass an int also without loss of any information. And function algorithm is just one line of code, because to take cube of something, we would multiply that argument by itself 3 times, and then we'll return the computed value. Okay, so in pseudocode or in algorithm, the function looks like this. Return type is double, name is cube. It's taking just one argument whose type is double. Inside the function, I'll have a variable called value. I'll multiply arg by itself 3 times, that's the cube, and I'll return the value, and that's the end of the function. And now we see the source code for this pseudocode, and that would be like this: double cube, double type, argument is double type, name is cube, return type is double, and I have a local variable value, which is arg into arg into arg 3 times. That's the algorithm, and I return that. So function has these 3 parts: header, algorithm, and a return statement. Okay, so do try to remember that. There are C++ requirements about return statement. Compared to other languages, C++ coding has some strict requirements from the return statement. We just give a summary here as a rule for C++ return statements in CS1 class. And I need to say here, I don't care what my ebook says, this is the latest. I have to make one place I've made some changes in C++ in ebook that would be made, but this is the latest on 12th April 2020. This applies. Rules about return statement. Rule 1. There can only be just one return statement in entire value returning function body. Just one. One. Not 2, not 3, not 5, 1. It can only return one value. It cannot return 5 values, 3 values. It can only return one value. And the return statement must always be the last program statement in the function body. Single return statement and last value. Violation of above rules, though allowed in other language, will not be allowed in CS1. Okay, so how would it look and feel? You'll have a data type here, you'll have function name here, you could have several, okay, this comma is wrong, there's no comma here, okay. So you may have many arguments, data type, this is data type of this argument, this is data type of this argument, and you might have more. And then you'll have code here, and then you'll return variable of same type as this. Data type here and data type here same. And once again, I cannot say this enough time. Those who don't want to listen to anything, please listen to this. There's only one return statement in entire function body, and that is the last statement in the function body, just before this curly brace. That's it. Okay. Okay, so that's video 1, which was on basics. We'll do some more basics in the video number 2. And after that, I believe I have a number of videos already done in the past. I'll just integrate them into our canvas. And then I'll do the design example 6. And then we'll be done with the topic of functions. So this is Dr. Satish Singhal, PhD, Professor of Computer Science at Camino College, Torrance, California, saying goodbye to you from video number 1.